Okay, let's pick up where we left off. Sorry, the video cut off, so I had to record it again. We were talking about piecewise functions here, and we were kind of just using this graph right here to figure out the output values and then the input value for it. So let's look at number C, or part C. Complete the rule for g of x so that the graph represents it. Okay, this is the function right here. And here are all of the outputs. And here are all of the inputs, right? The range. Oh, sorry, the domain, okay? So let's look at this. It's saying the output is -10 whenever x is either -15. -15 is less than or equal to x, and is less than -10. So -15 is right here, closed circle, right? And then it keeps going until -10, which is an open circle. And then from here, the output is -10, right? And then next, the output is -8. Okay, so this one's going to be -8. For when the input is -10, less than or equal to x, which is less than -8. Okay, and then the next one, the output is -6. When the input starts from -8 again, and then less than or equal to x, which is less than -1. And then now the next output looks like right here jumps from here, from -6 all the way up to +2. Okay, +2 when x is -1, less than or equal to x is less than, -1 is less than or equal to x less than 1. Okay, and then the next one, the output is 4 when you start at 1 is less than or equal to, I'm assuming this is 10. It starts at +1. Less than or equal to x less than 10, right? And then again, the output is 8, starting from the input 10. Output is 8. 10 is less than or equal to x less than 14, 15. Yeah, there you go. Okay, so that's that. Okay, a group of 10 friends played a number guessing game. They were asked to pick a number between 1 and 20. The person closest to the target number wins. The 10 people made these guesses. Okay, so these are the guesses, right? So the 10 people that are playing this guessing game was that. The actual number was 14. 14 is the actual number, okay? Complete the table with the absolute guessing errors. Absolute guessing errors. So, I need to put that on the poster, huh? At 14, how far was the guess 2 from 14? 12, right? How do you figure that out? You just do 14 minus 2. You get 12. How far was 15 from the guess 14? It was just one number off, right? How far was 10 from the number 14? It's 4 numbers off. How far is 8? 6 numbers off. How far is 12? 2 numbers off. 19? That's 5 numbers off. 6 numbers off. 9 numbers off. 4, 7 numbers off. And then this one is just 5 numbers off, okay? So just notice some things here. 19 and 9, they're both absolute guessing error is 5. So that means both of these numbers, right? Both of these numbers have, for different inputs, they have the same output. Different inputs, they have the same output, right? That means that both of these numbers, 19 and 9, have the same distance from 14. Okay, they have the same distance from 14. They're both 5, right? How far is 19 from 14? 5 numbers. How far is 9 from 14? 5 numbers. And then we're going to graph these. Okay? So the guesses are our x values. And then the absolute guessing error are our y values. Input, output. So at 2, guess was 12. At 1, guess was 15. Right? At 4, guess was 10. Whatever. At 8, guess was 6. At 2, guess was 12 again. And then at 5, guess was 19. Whoa, hold up. Sorry, at 19, I guess was 5. I was like, oh, that looks weird. And then at 6, or at 20, the guess was 6. And then at 7, the guess was 7. Or at 5, the guess was 9. 5, 9. And then at 7, the guess was 7. And then at 9, the guess was 5. 9, the guess was 5. Okay. So you have this these points right here. Right? And if you were to connect all the dots, this one kind of looks weird. I don't know why that's all the way up there. For 1, that's 15. Bro. Sorry, at 15, it's 1. That's why it looks weird. At 15, your guess was 1. There you go. Oh, and I messed that one up too. At 10, I guess it's 4. At 10, I guess it's 4 should have been there. And at 8, I guess it's like, okay, everything else is good. At 12, the guess is 2. I messed up another one. Oops. 12, I guess is 2. And 19 is 5. 20 is 6. 5 is 9. Yeah, okay. Now we're good. So it looks like 14 is obviously the vertex here. You're going to connect the dots like that. And connect the dots like that. So again, you get the absolute value function. Okay. If we were to graph this, vertex is at what? 14 and 0, right? Because the actual number was 14. Okay. So what is our function going to look like here? The absolute value of x, right? But remember, it's from the distance from 14. The distance from 14. So that means, remember, when you're finding the distance of something, you take the input and you subtract from the actual guess. So like the guess was 2 and you subtract from the actual guessing, the actual guess. So 14 minus 2. So that's going to be 12, right? So I'm subtracting. Okay, I'm just going to take, do it like this. And then take the absolute value so that it's always positive. Okay. So that should be the graph here, negative 14. Function n gives the absolute guessing error as a function of the number that each friend guessed in x. Guess all statements that are true. Oops. When the guess is 6, n of 6 is equal to 6. When the guess is 6. Is that true? Is it going to be 6 to 6? Nah, right? Because if the guess is 6, that means the guessing error, I'm going to call it the absolute guessing error. AGE, absolute guessing error. How far is 6 from 14? That's 8? Yeah, 8. So it shouldn't be 6 equals 6. N of 6 is equal to 8. When the guess is 13, n of 13 is 1. That's true. Because when the guess is 13, how far is 13 from 14? The absolute guessing error is 1. So n of 13 equals 1. That's true. The equation n of x is equal to x minus 14 gives us the absolute guarantee. Yeah, we checked that right now. And then what is it? Plus 14? No. That would be if the vertex was at negative 14. right? That's this one. Okay, so that's wrong. Nice. Okay, here are 4 equations of absolute value functions and 3 coordinate pairs. Each coordinate pair represents the vertex of the graph of an absolute value function. Match the equation of each function with the coordinates of its vertex of this graph. Okay. Remember we talked about this, right? So x minus 9. That means when we have a coordinate graph, right, that's the distance. Okay, this is the regular one. It's just a V shape, right? When there's nothing, when it's just x, okay? But technically speaking, it's x minus 0, right? Because that 0 is telling us where the vertex is going to be on the x-axis, okay? So that means, right, if we tweak it a little bit, right, the distance x minus 0. So if we tweak it a little bit, like this one right here, if it's minus 9, then that means these are all the points from that tell us the distance from that 9, right? So it starts from here and then it kind of goes outwards. So what's the vertex point here? That's 9 and 0. Okay, so these two are matched. Okay, what about the next one? Q of x, the absolute value of x plus 9. So notice how this plus 9 is outside of the absolute value, right? Outside of the absolute value. So how does that change up our vertex? So if it's on the outside, that means you're done with the absolute value. You have the absolute value. And you're tweaking it up or down, right? Plus 9 means you're going up 9. Down 9 means, minus 9 means you're going down 9. So since this is plus 9, right, you have the absolute value of, so you're just tweaking it on the y-axis. So that's 0 and 9. That's 0 and 9. But this one, they don't even have, actually, they don't have that option, right? But if they did, those would match, okay? Okay, go next. What about r of x is equal to x plus 9, okay? So remember, subtraction shows the distance between two numbers. So then if you were to rewrite this, this is the same thing, right? So this plus 9, when it's x plus 9, that's kind of telling us the distance from that point, negative 9, because negative and negative make a positive, right? So if we look at this graph, negative 9 is here. So this is the absolute value function for that. So then that our vertex point is negative 9 and 0. Okay. And then the last one, absolute value of x minus 9. Again, they already did the absolute value function. Now, after doing the absolute value function, they're tweaking it going up or down. Then it's negative 9, so this one's going to be down. Okay, so where is this vertex point? 0 and negative 9. 0 and negative 9. Okay, there you go. Here's a graph of the function. Select the equation for the function represented by the graph. I think at this point we've got enough practice, right? You should be able to kind of get this right away. Negative 5 down here. It's adjusted on the y-axis. Okay, so that means we took the absolute value first, and then is it going up or down? Up or down? That's down, so it's going to be negative 5. Okay, negative 5. So it should be this one. Now what about this one? Right? Now it looks like they moved it on the x-axis. So then that means we're taking the distance from that point too. So how do you show that you're taking the distance from that point? Remember, distance, subtract. So all the points that are like far away from 2. The distance x, give me each guess from 2. Okay, so the distance from 2, that's this one here. That's it. Okay, just watch this video. I hope you study for your test.